In this example, we're going to evaluate this double integral. So to start, we always look at the inside integral first. So in that case, we'd be looking at the integral of sine of y over y with respect to y. If you look at this a little closer and you try some of the techniques you've learned from Math 12, you'll soon discover we can't actually do that integral, the inside integral, analytically. Okay, so in this case, our strategy to do this whole double integral is going to be to switch the order of integration. Okay, so we'd like to use dx dy instead. So unfortunately, it is not as easy as just switching the order of the integrals. It does not work like that. Instead, what we need to do is sketch the region we're actually integrating over. Okay, so we're not sketching what's in the integrand, we're not sketching sine of y over y. We're sketching the region that's been described by these limits of integration. Okay, so we'll look at the outside limits first. So notice here, we see that x goes from 0, and then it ends at 1. So we're starting at when x is 0, and we go to where x is 1. And then y. So recall, if we're looking at a region where we're integrating with respect to y first, it's the equivalent of shooting a ray parallel to the y-axis. So we're shooting a ray like this. And because it tells us that y, let's look at the y limits here, we see that y starts when y equals x, so let's sketch y equals x. Here's the line y equals x. And then it exits at the line y is equal to 1. Okay, so that's roughly, that should be a horizontal line. You get the idea. That's the line y is equal to 1. Okay, so the ray enters the region when y is equal to x, and it exits when y is equal to 1. So that means that the region that we're integrating over is this triangle inside here. Okay, and that's what we're calling R. Alright, so now that we have R, we can switch our order of integration as follows. So first, you're going to leave the integrand just as it is. So you're going to leave sine of y over y inside here. And now we'd like to look at dx dy. So let's start with our outside limits first. And so you go look at your region R and you say what's the smallest that y can be and what's the biggest it can be. And you see in this triangle the smallest that y can be is y is 0, and the biggest it can be is y is 1. Okay, those are your outside limits of integration. To get the inside limits, we're now going to take a ray and we're going to shoot it parallel to the x-axis, or a ray that's parallel to the x-axis, so just like this. And we're going to look at where this ray enters, right there, and where it exits the region. So you can see this ray enters along the line x is equal to 0. And it exits over here along the line x is equal to y. Okay, so these are now our new limits of integration. So notice, these new limits are not the same as just taking our original integrals and flipping them. You have to draw the region to see what your new, and shoot your arrays, and then you can set up your new limits. Okay, so on a new sheet, let's work on this integral now. Okay, so now we're going to look at this as now our inside integral. So now we're thinking of x as a constant, or excuse me. Okay, I had those written backwards, sorry, so let's go back to this page. So we switched it so we have dx dy. Okay, now we're on the same page. So we switched it so we have dx dy. So our inside integral, we're integrating with respect to x now, and so we are thinking of y as a constant. Okay, so we can actually think of this whole sine of y over y term as just a constant, and so we can pull it out front of that integral. So I have sine y over y, and now I'm just integrating 0 to y dx, and I'll still have dy for my outside integral. Okay, so this inside integral, this is just going to become y. And now I'm going to get the integral from 0 to 1 sine of y over y times y dy. That's going to simplify right there, and I'm just going to be integrating sine of y. Okay, we know that's just negative cosine of y, so I'm going to get negative cosine of 1 minus a negative cosine 0, so that's going to become a plus 1. Okay, and that's it.